Well, hello and welcome back to the state of affairs after working on the LED project for the OxyLED conversion. A couple of things. This was a project that I was going to take just a short amount of time, but like most things, ended up ballooning into an entire day, and now this is the second day. Learned a lot of things. Interesting discovery with the battery being glued down. I actually got the battery completely out of one of the enclosures. It completely came out and it didn't like that. It's actually glued, at least in the case of these, this part number, there it is there. And when these things were manufactured, they glued this all the way down. So they must somehow like glued it, slid it in, and then maybe heated it up to get it to stay in place. But even with the plastic tools and being gentle with it, the cell kind of started to puff up. And so it had to go into my lithium-ion meltdown containment tube because it was starting to get a little unhappy. It has since calmed down, but it is definitely puffier than this one that's in this aluminum chassis. And so that may have been due to the fact that I was trying to push on it. But I thought I recall, and I may have to go back and look at the video. Actually, this has come down quite a bit. There's not much puffiness at all. What I did end up doing is, toward the end of the video, you saw that I was discharging it through a 10 ohm resistor. I just kept it discharging. The voltage was very low, down to about 0.05 volts, so 50 millivolts. And so I'm just going to continue to discharge this thing all the way down for probably about 4 or 5 days. And then I might consider neutralizing it in a saltwater bath for another day, and then it's going to go to be recycled. This battery, I don't feel comfortable nor confident charging it back up again, especially because it has no actual protection on the battery, and it's a pouch cell. And generally speaking, these pouch cells, while you can form them into a variety of cool shapes and stuff like that, they're not as stable as the cylindrical cells, the 18650s or others similar to it. When it started puffing up and I could actually push on it. Now it's not, it's kind of back to the way it was. I could kind of press on it, it was kind of inflating. And I just kept the infrared thermometer on it, and it got up to about 80 degrees Fahrenheit. It did not get very warm. So nothing spectacular, but I am going to continue to discharge it for a couple more days and then dispose of it safely. So what did I learn from that? Well, I'm not going to try to take this battery out. That is just, it's going to be another battery just like this one. And so instead what I decided to do, 2 of the installations that I have are going to be used in a closet. And this aluminum, nice as it is, this aluminum frame, I don't need it. So what am I doing instead? So it's kind of a little bit of a hack, but what I'm intending on doing here is took out the PCB. Here's the PCB here. Reattached the diffusion lens for the passive infrared sensor. And then I decided to take, just for the heck of it, the diffusion plastic, reattach it, and then with just some electrical tape, hold it in place. And then on the opposite side, what I'm planning on doing is, where this is going to be located, it's going to be up on a ceiling and in a closet. So you will, unless you're looking up at this thing, you're not going to see it. And even if you do, all you're going to see is this. So, and these don't use, this draws about 1 watt to about 1.25 watts when it's running. So it doesn't need this aluminum chassis to cool anything down. It's not running at a high duty cycle or anything like that. And even if it did, it's running off AA batteries, so it'll just discharge it down and then the batteries will be dead and I'll have to recharge them. So it doesn't need the aluminum case to keep it cool. And what I didn't mention is for 2 of these, when we moved, we ended up leaving the magnetic strip tape in the closet because you couldn't get it back down again. I looked to buy magnetic tape for this, and it's not worth the cost compared to like command strips. So we just used command strips instead to put this on a bracket, and it was being held in by a bracket. But the bracket it doesn't work as well as it could. So this solution, while it may seem more hacky, seems at least to be a better solution. I'll actually show a video of the final product, but I'll kind of walk you through the final steps here. What I've done is I've soldered up 2 wires to the battery plus and battery minus, and I'm going to tape this down to kind of give it additional mechanical securement. And then this is going to run off in the closet to another smaller couple pieces of command strips, really small sections that will just kind of hold the wire in place along the inside of the closet so you can't see it, and then run down to a battery pack like this one. And what it will be powered by is these freshly charged Eneloop Pros. And so the Eneloop Pros are, this is where the cost of, like, I was thinking, oops, this is a little bit of a tight fit in these particular battery enclosures I bought. But they do hold the battery, or they're not going to. One seems like it might be defective. Well, I got 6 more, so let's try another one. Oop. Oh, they did come with screws. That's nice. I'll put a link to these in the description. They're nice little battery holders, except for the one that might be defective. No, maybe I just wasn't pushing down far enough. Let's try one more time. This one. It's a snug fit because these high capacity, or even just I think the regular Eneloops are a little bit, yeah, they snap in. It means that it holds it in well. That's nice. But it has a door that clips down with a decent amount of friction, but they also supply screws, so you can screw it down in place if you really wanted to. Pretty nice. So this will provide, making sure that switch is off. No, it's on, so let's not dead short the batteries. So this is 1.2 volts nominal times 3, so 3.6 volts. I think I mentioned this in the beginning of the previous video. 3.6 volts at about 2.5 amp hour. That is some number that I'm not going to be able to get off the top of my head. Bom, 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 bom. Help me, calculator. Where are you? There you are. Okay, so get that turned on there. 3.6 volts. We have, oops, 1.2 volts nominal times 3, because they're in series, times 2.5, which is the amp hour rating for these. So it's 9 watt hours in this pack. And even if we are super conservative and say 3.6 times 2.45, because that's the minimal amp hour capacity for these cells, it's 8.82 watt hours. The 8.82 watt hours divided by the 3.50 is more than 2.5 times the capacity of the cell that was originally in this enclosure. I was getting about 3 weeks on a charge, now easily up to 2 months. Finishing this off, I'm going to tape this down here. So soldered it down. I don't like surface mount wire terminations. I really prefer the through hole terminations, but they wanted to keep the board cheap. No, there's no drill holes for anything in this except for I think on the ends for the switch and maybe the micro USB port. Everything else is surface mount. So, oh well. All that's left to do here is tape this down, and then I'm going to tape along the length of this to keep these wires kind of together and to keep them from curling as much. Stick the 2 command strips on here right around where the resistor banks are. I did think about covering this entire thing with electrical tape just to protect everything, but that electrical tape I think is going to pull away from the PCB, and it's just not going to, it's not necessary. Nothing conductive on the ceiling. All right, that's what I'm going to do. So let's get to it. So I got one right there, just holding that in place. And then I'll put one right at the edge here. And I might wrap that a few times. This end I think has the switch on it, yep. So I can wrap that a few times just to get it nice and snug around the end to provide some securement for the wire. Would I do this for a high voltage application? Absolutely not. But we were talking about a working voltage of about 4.5 volts and maximum current of about, these wires are rated at about 2 amps because they're 26 gauge. So it's probably going to be inherently limited by the impedance of the wiring. So yeah, this is fine. Not the way that I envisioned this project would finish, but that's usually how these things go. And when you have something that you've been using for several months, like closet lighting, even though it's not a necessity, and then it suddenly just isn't there anymore for several days, you begin to notice. And then there's a bit of a encouragement to finish the project. I'll give it one more wrap, just trying to stay away from the LEDs, so I'm not just like, let me do that without overwrapping it like that. So I'm trying to stay away from the LEDs so we still get, whoop. So I'm not just like covering up the LEDs with electrical tape, which would defeat the purpose, but that seems like a pretty good. This might be a tip that maybe, I don't know, maybe it is a top tip. But when you're using electrical tape, pulling on it, just stretch it while you're wrapping it, actually gives you better adhesion, because the vinyl like heats up momentarily, the adhesive heats up a little bit, and then you're stretching it around, and so you get a nice tight fit, as opposed to just kind of wrapping around it without any sort of tension on the tape. And I think they even suggest this. I'm gonna look at, yeah, clean surface, stretch tape for tight fit, progressively overwrap 1/2 of the tape with, that's for wrap, I mean if you're wrapping around something. Final wrap without tension. Makes sense. The final wrap just to kind of give it a cover. This case doesn't matter. I think what they're referring to in this is for the electrical insulation. Because if you stretch this out for your final wrap, you're actually decreasing the dielectric strength of the vinyl, which is dielectric, meaning how much voltage resistance is there from one side of the tape to the other. So, and I maybe can do a whole video on dielectric strength, but basically for low voltage applications, it's not really that important. Well, it's not important at all. So, okay, everything is all set to go. All I'm going to do now is stick on one side of the command strips. And these are Velcro strips. So just in case I need to pull this down to do anything with it, I prefer to do it with the Velcro strip as opposed to just like straight command strip. So that it's got a little bit of user serviceability still baked in. And it gives high clearance, so it clears all of the other stuff so that when I'm putting it against the ceiling, you're actually pushing on the tape or the command strip and not on components and other things like that. So it maintains the clearance nicely. We'll get that all set to go. And I put that one roughly over there, and I'll put this one. I know it's over all the current limiting resistors, but I don't really have another place to put it. But I don't think those resistors are going to get very warm. There we go. So we are pretty much set to stick this on the ceiling. What I want to do before I do that is quickly tape off this. So just every few inches, tape these together with a half strip of electrical tape just so that it helps keep the wire straight. It's easier for cable management, all that good stuff. Let's do that. Cut this into a half strip. I've been always doing projects like this. just never, I mean, and actually I would record a lot of the stuff that I would do and share it with friends and family, but I never thought about uploading it to YouTube. You know, I think there's an important lesson that's often missed, and I know there's a lot of YouTubers that talk about this in this space that I'm really happy to hear. It's wonderful to hear, honestly. The embracing of failure. As many times as you have successes, there are failures, and we call them failures, and we think that, oh my goodness, I failed. I set out to do something and it didn't turn out the way that I wanted it to. And I'll be honest, like a little bit of this project, when I got to the point last night where this battery was getting unhappy, or a little unhappy, I was like, God, this is just a failure. Like this doesn't even, I can't believe that I took apart one of them. It was super easy, 5 minutes, and I had the whole thing apart, and I was like, this is great. Of course, I forgot to set up the camera. And then I turned the camera on to do the second and third one, and well, you saw what happened. You take a moment, and it's perspective. You're the one perceiving whether or not it's a success or failure. Society may have its own opinions of what that actually means, but often those even change of what truly is a success and what truly is a failure. Sorry, I'm off camera a lot here doing this electrical tape work, but that to me is something that is worth really taking the time when you're working on projects like this and they don't work out the way that you think that they should, or that you had in your mind's eye or something like that, to take a step back and to just look at what you set out to do and the things that you learned. And honestly, the things that I've learned from this project is so valuable in and of itself, because what's really needed. I kind of thought, well, I'll just buy a bunch of lithium-ion batteries and stick them into these enclosures and spend $30 or $40 on batteries from Alibaba. They make the exact ones that I needed, and then I'm like, well, it's 30 days to ship that. I kind of want this, just kind of want this done. And then I look at the envelopes, and I'm like, I already have these for the smaller lights. Why not use this for the bigger lights and get more capacity out of it? And I'm not futzing around with, waiting for batteries that may or may not fit in the space that I need, et cetera, et cetera. So like the end result is this may function just perfectly fine with some electrical tape stuck to it for many years. And it may not be as pretty as I envision, but like it's what you want to get out of it, what you're looking to get out of it. And if it's learning about something, like I didn't set out to go like, I want to make the prettiest, conversion to, whatever. It was to learn, and curiosity as the name of the channel. And so this is the result of that curiosity, and it may look a little sloppy or messy or whatever, and that's, you're entitled to your opinion on that. But I feel like there's so much to be learned by not being afraid of failure. And then even when you think you have failed, that you look at that and go, is it truly a failure, or is it an opportunity for even more learning? I'll be honest, I was quite mad when that battery started getting, cranky, and I couldn't get it out of the enclosure. And I'm like, why would they glue it down so much? And it's like, that's what they did. It's not the OxyLED did not manufacture these going, oh, user replaceable. Like I had put all this expectation as to what I thought, because there was one that I had that I bought more recently that they would all be that way, and that's not how things go. So anyways, okay, so this is finished up. Yeah, the wire is kind of still funky, but when I stretch it out, it'll get happier. So what I'm going to do, the final step here, is to wire this up to the battery. I'm going to strip the wire back about 3/4. That's about a 1/2 inch. About a 1/2 inch back, twist it. And then I'm going to do the same thing on the battery side. Strip this back about a 1/2 inch. Now what I'm going to do is, I get a little funky here with the wires coiling up. I'm going to twist them around each other. I've been taught there's several different conventions, but like tin them first and then tin them together. My preference is to twist them if they're both stranded conductor. So one of them is not a solid conductor. If they're both stranded, then my preference is to twist them together, which you're not going to get a great mechanical securement, but you're going to get eventually one will hook into the other. And then the reason why I do this is when you flow solder into the braid or into the strands, then it tends to flow in between and create a much better mechanical securement. So I need my solder. I have no idea where my solder went. Oh, it's over there. So I'm just going to flood some solder. I should say flow, not flood. Some solder in there. And I don't have my... Hey, just let it smoke. Just let it smoke for a while. So let that cool for a second. Okay, so this is good. What I was looking for is once it cooled down and everything, not that it takes that long for it to cool down, that I got solder all the way around and it wasn't, you don't see any bare strands, and that's mechanically really strong. Strip the wire and do the exact same thing for red and white. And then we'll turn it on and test it, make sure that it works. I thought about using, this is 24? 22. This is 22 gauge. I had some wire wrap that's 30 gauge, but this pulls about a watt and a half when it's on, even though it's for a short period of time. And I could use it, but then the internal resistance between the pack and the driver climbs. It just made better sense to use 22 gauge wire so that the impedance is way lower and then this runtime is higher. It would have been it would have contributed to somewhere around the order of like 5 to 10% degradation of battery life, which isn't too bad, but you know, it's not. I have the wire, so why not use it? The only benefit being the silicone wrap wire is much more friendly for moving around than PVC wire, which tends to bunch up like this. But eventually it'll calm down in a couple decades. No, I'm kidding. I kid. Okay, so having a little more difficulty with this one, as you can tell, which is why I keep talking. Okay. I did have a helping hands, but it broke, and I never particularly liked the helping hands. But I might look to get something that can work like a helping hands without... The problem I had with the helping hands is that it used alligator clips, and the alligator clips would crush, like they would bite into the insulation of the wire, especially for low gauge wire and silicone wrap wire. So it's like it just wasn't a great solution, at least for me. But there are some really nice ones out there that do the job beautifully, but I just don't have the need for it that often. But this is one of those moments. Okay, both are connected. Let's do a quick test to make sure that it actually works and doesn't start on fire. I don't think this is actually turned on right now, which that's the funny thing, is that now that I have this all wrapped up, I have to go find the switch and get it flipped to auto. And it will be in auto pretty much for the rest of its life. Hey, there it goes. Cool. So turned on, it's on auto now, so it's not going to do anything for a little while. But awesome, it worked. Maybe I'll flip it to on just for a few moments. And we can get a quick, actually, while it's on, this will be fun. We can measure the voltage here. We'll do a couple different measurements real quick just to kind of prove out the it's not really quite transmission line, but it's a lengthy length of wire. Just 1 second and I will come back and we'll do that test.